In this video, I want to show you how we can find limit of this function when x approaches 0 using the squeeze theorem. These type of functions that you can see here are famous to Dirichlet functions. Dirichlet was a German mathematician who defined functions like this, and this is one example of Dirichlet functions. We want to find limit of this function when x approaches 0 using the squeeze theorem. Before we start finding the limit, let's focus on the definition of this function. If x is irrational, if you remember, irrational numbers are numbers like radical 2, radical 3, 1 over radical 10, 1 over radical 2000, pi over 200. These numbers are irrational. If x is these type of numbers, then the value of the function f is x to the 2. But if x is rational, like 1, 1/2, negative 2/3, 0, negative 1 over 200, for these type of numbers, the value of the function is always 0. Now we want to find limit of this function using the squeeze theorem. But why we need, or why we can use, it's a good idea to use the squeeze theorem for this function. When x approaches 0, the numbers that are close to 0 can be either rational or irrational. For example, 1 over 100 is a number that is close to 0. But 1 over, for example, 100 radical 3 is also a small number close to 0. So when x approaches 0, we don't know the function f is x to the 2 or is it 0. Which equation we have to consider for f. And for this reason, if we can use a squeeze theorem for finding limit of f of x when x approaches 0, then we don't need to focus on f of x. If you remember a squeeze theorem or sandwich theorem, we are finding the limit of the left function and limit of the right function, and we are not thinking to the middle function. And if the limit of the left function and right function are equal, then limit of the middle function is also that number. For this reason, because this is not a normal function, so for this reason we want to use squeeze theorem. Now attention. The function f of x is either x to the 2 for any value of x or 0. And let me mention something to you. X to the 2 is always greater than or equal to 0. This should be clear. Because any number other than 0 to the power of 2 is positive, and if x is exactly 0, 0 to the 2 is 0, so this equals here, this equal here is for that reason. So it should be clear that x to the 2 is always greater than 0. So our function f of x is either x to the 2 or 0. For this reason, it should be clear that f of x is always greater than 0. Because if f of x is 0, then 0 is greater than or equal to 0. And if f of x is x to the 2, it is also greater than 0. So far we know that f of x is always greater than or equal to 0. And also we can claim that f of x is always less than x to the 2. Because if f of x is 0, then 0 is less than x to the 2. It is obvious. And if f of x is x to the 2, x to the 2 is less than or equal x to the 2? Yes, it is. So for every value of x, f of x is between 0 and x to the 2. Now we have the thing that we need for using squeeze or sandwich theorem. We want to find limit of f of x when x approaches 0. Instead of that, we are finding limit of the left function, limit of the right function when x approaches 0, and if these two limits are equal, then the limit of the middle function is also equal to that number. So now we have to find limit of 0, the left function is 0, when x approaches 0. Because it is 0, so the limit is also 0. What about the limit of the other side? What is limit of x to the 2 when x approaches 0? With a direct substitution, this is also 0. Because limit of the left function is 0. Limit of the right function is also 0. Now, from Squeeze Theorem, so here we say, from Squeeze Theorem, we can conclude that from this, we can conclude that limit of the function f of x when x approaches 0 equals 0. Because the limit of the left function is 0, limit of the right function is also 0, so the limit of the middle function f of x is also 0. So limit of f of x when x approaches 0 is 0. Now let me add another question to this. What is the limit of this function if x approaches, let's say, for example, 3? What about this? What is limit of this function when x approaches 3? When x approaches 3, the story would be different. Because attention, when x approaches 0, x to the 2 when x approaches 0 is 0, and 0 is 0. So these two equations, when x approaches 0, both of them approach to 0. But when x approaches 3, x to the 2 approaches 9, but 0 is 0. So the story would be different. But how we can find this limit? What method we can use for finding limit of this function when x approaches 3? Here you can do it this way. Basically the idea is to show that the limit does not exist when x approaches 3. But how we can do it? We consider two cases. We consider one case when x is rational. The other case is x is irrational number. If x is rational, we know that if x is rational, then the function f of x is always 0. We want to find the limit of f of x while we consider, please attention, we consider in this case x a rational number as x approaches 3. Whenever x is rational, f of x is 0. So we want to find limit of 0 when x approaches 3. Because the function is 0, so its limit is also 0. But when x is irrational, limit of the function f of x when x approaches 3 would be equal to limit of x to the 2, because the equation when x is irrational is x to the 2. When x approaches 3 equals 9. Now, from this we conclude that because limit when x is rational is 0, when x is irrational is 9, these two limits when x approaches 3 are different, so the limit does not exist. So from this reasoning, we conclude that limit of f of x when x approaches 3 does not exist. Because for rational numbers, the limit is 0. For irrational numbers, the limit is 9. They are different, so the limit does not exist. Before I finish this video, let me explain something in general for you about this function. This function has limit only at 0. For any other number, like the one that I showed you, like 3, 2, -1, 5, any other number than 0, the limit does not exist. And the way that you can prove it is exactly like this I did for 3. For any other number like 2, 5, -1, you can do it same way, and you can prove that this function, the limit of this function at those points, does not exist.